Good morning. Today we are going to see the indeterminate truss and our analysis of truss. And in this, we are going to see the temperature effect, or you can say temperature change effect. So any one of the member undergoes a temperature change, and that we will see. Now was asked in 2017. Determine the forces in all members of the truss as shown in figure due to fall of temperature of member BD by 30 degrees centigrade. So we have fall of temperature of member BD 30 degrees centigrade. So whichever member is with lack of heat or temperature change should be considered as redundant. Cross-sectional areas of all members are 1500 mm square. Alpha we have 0.0001 per degree centigrade. That we can write it as 1 into 10 raised to minus 5 per degree centigrade. So now static indeterminacy. R we have 3, DSE we have 0. Then we have DSI, members we have 8. So we can see this 1, 2, 3, 4, 5, 6, 7, 8. And joint we have 5. So 10 minus 3 we have 7. So 8 minus 7 1. DS we have 1, internally indeterminate. So we have truss internally indeterminate. And as it is internally indeterminate, so we have to consider member as redundant. And which member we have to consider? The member which undergo temperature change. And we have temperature change for member BD. So we have number of redundant DS1. Consider member BD as redundant. As no external loads acting on this is most important. So we have all P forces as 0. So now we will start to analyze it. So we have joint E with 2 members only, so both become 0. Then we will consider unit force in BD because we have BD as redundant. Now you can say angle we have 45 degree, and already we have seen in NPTEL assignments. So we have, if this has 45 degree, all other for isosceles triangle we have 0.71 compression, and AC also we have 1 tension. So we can see by considering joint separately, we have taken B joint, and by using summation Fx0 we will get FBA, and considering Fy0 we will get value as FBC. So both we have compression. So we have shown this BA and BC both compression. Now go to joint C. Joint C we have actually this is 0.71. So we will apply summation Fy0, and from this we will get FCA sin 45 minus 0.71, and we will get value of FCA equal to 1. That is tension. So knowing this tension 1, we will go to 1 cos 45 plus FCD, and from this we will get F not AB. So we have this as FCD, and that is equal to minus 0.71. So CD minus 0.71. So if we will go to DA, then we have again 0.71, which will be compression by considering joint D. So if we will consider joint D, then what we will get in that joint D? So we can have joint D like this. So we have this as 1, this we have 0.71. Then summation Fy0, automatically we will get this value as 0.71. This is joint D, and this will be force in DA. So likewise we will get value of K forces. Now we will prepare the table as we have prepared for others also. So AB we have data value of A 1500 that we have seen. So if we will go to the problem, then you will come to know all members we have 1500. So if we will put here, or if we will consider at end, then also it's okay. All A, B, B, C, C, D, and then A, DA. So we have actually these four members. You can see we have these four members which are A, B, B, C, C, D and AD or DA. So we have these values minus 0.71. Both diagonals we have AC and BD we have 1, 1. So now we have total, if we will consider this, then we have summation K square L upon A 8.34. Now we will go to dr is equal to dr temperature plus F into R. So we have minus L alpha T. Actually, what is formula? We have L alpha T, but here fall of temperature, so it will be minus sign. If it is increase in temperature, then we have increase in length, so plus. If we have decrease in temperature, we have decrease in length, so minus. Then we have plus summation K square L upon A into R. And from this, if we will substitute the values, we are going to get value of R 14.39 Newton. So knowing this value of R 14.39 kilonewton, we can find forces in all members. Now what will be force in AB? So now we have AB that is equal to, we do not have any P force. So directly we have 14.39 into minus 0.71. And we will get this value that is equal to minus 10.22, and that is 10.22 kilonewton, and that is compression. Now we have AB, then we have BC, then we have CD and AD. We all four we have in the same way. And then we have that is in AC. So AC we have 1 into 14.39, and we will get it as 14.39 kilonewtons, and it will be tension. AC and BD we have same. So you can see this. We have this will be 10.22. So all we have 10.22 kilonewtons. Then diagonal we have 15.67 kilonewton, 15.67 kilonewton. So this diagram plays very important role because this is final forces. This diagram we have final forces, and last diagram we have K force analysis. So that difference we have to keep in mind, that is of K forces, and then we have that is P forces. In this we have P0. Now as we do not have K force in this one, then we are going to get both these as 0. If we have P force, then if K is 0, then it will be PF equal to P. That we have to keep in mind. So this is about your temperature change, and now we will stop here only. The remaining part we will see that is in next lecture. Thank you.